Welcome back to my channel. In this video, I want to share a better way to use the HC-SR04 ultrasonic sensor with Arduino style programming. From what I have seen, many HC-SR04 tutorials already explain the trigger and echo signals very well, so I will not repeat too much of the basic working principle here. Instead, we will focus on the coding method. Most examples use pulseIn, delay, or a waiting loop to measure the echo pulse. This is fine for a simple demo, but in a real embedded system or robotics project, it can waste CPU time. While the microcontroller is waiting for the echo signal, it may also need to control motors, read encoders, handle communication, or process other sensors. So in this tutorial, I will show you an interrupt-driven and timer-based method using STM32duino on a Nucleo G474 board. The driver is object-oriented, non-blocking, and uses a callback function to notify us when the distance result is ready, or when a timeout or error happens. The library is called HC-SR04, and it is available from the Arduino Library Manager. By the end of this video, you will see how we can move from a simple beginner-style ultrasonic example to a cleaner driver structure that is more suitable for real STM32 Arduino projects. Let's get started. For the hardware setup, I am using the Nucleo G474 redevelopment board. You may also use other supported STM32 Nucleo boards, because this library is built on top of STM32duino. Just make sure the board you choose is supported by the STM32duino board package in Arduino IDE. Also, please install STM32Cube Programmer, because STM32duino may use it for uploading firmware to STM32 boards, especially when using ST-Link, UART bootloader, or DFU upload methods. For the SR04 connection to the Nucleo board, connect the sensor power pin to 5 volts, and connect the ground pin to GND. Then connect the trigger pin to D8, and the echo pin to D7, as shown in the photo. For the Nucleo G474 D8 is mapped to PA9, and D7 is mapped to PA8. If you are using a custom STM32 board, please make sure your board definition maps D8 to PA9 and D7 to PA8. I assume you have already installed the Arduino IDE. Now, we are going to set up STM32duino so that the Arduino IDE can support STM32 Nucleo boards. Open the Arduino IDE. On the left sidebar, click the second icon. This is the board's manager. In the search box, type STM32. You should see a package from STMicroelectronics called STM32 MCU-based boards. Click Install and wait until the installation is complete. Come to the next. Click the third icon on the left sidebar. This is the Library Manager. In the search box, type HC-SR04. You should see the HC-SR04 library by GIGASITRON. Click Install and wait until the installation is complete. Then go to File and open Preferences. Under the Settings tab, look for additional Boards Manager URLs. Add the STM32duino Boards Manager link there. After the configuration is complete, close the Arduino IDE and open it again. Now we are going to test the library. From the File menu, create a new sketch. Then go back to the File menu again. Open Examples and look for HC-SR04. Under HC-SR04, select Basic Single Sensor. Go to the Tools menu. Under Board, choose STM32 MCU-based boards. Then select Nucleo 64. We choose Nucleo 64 because the Nucleo G474 belongs to the Nucleo 64 board family. Next, go to board part number and select Nucleo G474. Then go to Upload Method and select SWD. For this upload method to work, make sure STM32 programmer is already installed on your computer. Give me a moment. I am going to connect the Nucleo board to the computer using a USB cable. One important point about the sensor connection is the voltage level. The STM32 runs at 3.3 volts, while the SR04 sensor is normally powered by 5 volts. For the trigger pin, this is not a big issue because it's an output from the STM32 to the sensor. But for the echo pin, the signal comes from the sensor back to the STM32. Since the echo signal can be 5 volts, the best practice is to use a resistor voltage divider or a level shifter to bring it down to 3.3 volts. Some STM32 GPIO pins are 5 volts tolerant, but not all of them. To be safe and to make the design more reliable, I recommend using a voltage divider on the echo pin. Back to the code. Here, we use HC-SR04 to create a sensor object called Sensor1. The library supports up to 8 sensors. This limit is intentional because memory, timers, and available pins are limited. For most robotics applications, 8 ultrasonic sensors are already more than enough. If you look through the code, the library uses a callback function to notify the application when a sensor result is ready, or when an error or timeout happens. With this method, we do not need to wait inside a loop, and we do not need to use delay. The microcontroller can continue running other tasks while the ultrasonic measurement is happening. This is important in robotics applications, because the system may also need to control motors, read encoders, handle communication, or process other sensors in real time. You can read through the code by yourself. The structure should not be too difficult to understand. Now it is time to compile the example. Click the Verify button. If the STM32duino board package and the HC-SR04 library are installed correctly, the code should compile successfully. Now we come to the final step. Upload the code to the Nucleo board and check the results. After the upload is complete, open the serial monitor or any serial terminal. Make sure the baud rate is set to 115,200. You should see the distance readings from the SR04 sensor printed on the screen. As you can see, it is working well. I used a ruler to roughly compare the actual distance with the displayed values, and the results look quite good. If the sensor is covered too closely, or if no valid echo signal is received, the library will report an error or timeout. That is the end of this tutorial. I hope you enjoyed it, and I hope this library is useful for your STM32 Arduino projects. Thank you for watching, and see you in the next video.